Welcome to qnawire.
We have this cube here that can rotate freely about the diagonal from point A to point B, and we're asked to find what the mass is of this cube. And I went ahead and found what the angular velocity was, and the mass of one side of the cube is given, or we can write it as the total mass of the cube divided by the total number of sides, which is 6. And we're going to assume that in this cube that the x, y, and z axes are perpendicular to the faces of this cube. So to start, we're going to find the moment of inertia for a side perpendicular to the x-axis. So we're going to call that I of x1. And we can write that as 1 over 6 times m prime times a squared, where a is the length of this edge here. So it's 1.5 meters. And next we're going to write the formula for the moment of inertia for a side perpendicular to either the y or x axes. So I'll label that as I of x2, since this is with respect to the x-axis. So we can write that as 1 over 12 plus 1 over 4 times m prime times a squared. And we can simplify it as 1 over 3 times m prime times a squared. So now to get the total moment of inertia about the x-axis, we can take the summation of both of these moments, depending on which sides are perpendicular to which axis. So to write that out, so we have I of x. We can write that as 2 times I of x1, since there's two sides that are perpendicular to the x-axis, and then plus 4 times I of x2, since there is 4 sides that are perpendicular to either the y or z axis. So now we can just plug in the values for I of x1 and I of x2. So we can write this as, so we plug in these values, so both of these values here, which I'll write as 1 over 6 times m over 6. I'll write it like this. So 1 over 6 times m over 6 times a squared plus 4 times 1 over 3 times m over 6 times a squared. And this can simplify down to 5 over 18 times m times a squared. And since the cube is a symmetrical figure, we can say that the moment of inertia about the x-axis is also equal to the moment of inertia in the y-axis and also the z-axis. So this is equal to I of y, which is also equal to I of z. So next we're going to calculate what the moment of inertia is about the vertical axis. So we're going to write that the square root of 2/3 times A times the impulse is equal to the moment of inertia times the angular velocity. And this moment of inertia is just this value here that we calculated. So this whole term here will go into this value for the moment of inertia. So we're going to rewrite this. So the parentheses there, and then we'll rewrite this after plugging in I, that moment of inertia. So we plug in I, and then we're going to take this equation here and solve for the value of M. So we solve for M, which then becomes the square root of 2/3 times A times the impulse times 18/5 times 1/a² times the angular velocity. Now all that's left is to plug in these unknown values and solve for the mass. So we plug in A, we plug in the impulse, and then we plug in A, and then plug in the angular velocity. And then doing this calculation, we'll get a final mass that's equal to 93.6 kilograms.